So before we talk about the even and odd trig functions, I want to take a step back and talk about what an even function is. So if you remember from pre-calc, what an even function is by definition is if you plug in negative x, you get out exactly the same thing as the original function. What that graph was that we used to illustrate that in college algebra and in pre-calc would probably be the most common one was your parabola. Now, when you look at this, you have symmetry around the x-axis. So if you go through and flip this from left to right, it matches up on both sides. Now, what does this mean for the unit circle? So if I have the unit circle, and I have, again, this is my value of 1 for my unit circle. It means that for whatever x value that I have, so if I draw in two angles, let's say this angle here is my positive theta, and down going the other way, same value, but it would be a negative theta. What do I know about these 2 points on the unit circle? This value x and y are both positive. Down here at the bottom, x still stays positive, but y changes its sign to be negative. Now, this means that any time that I have the cosine of theta when it's positive, that's also going to equal x. But if I have that cosine of a negative theta going in the opposite direction, that also will equal x. This function is even. And again, that happens because it doesn't matter if I'm going in the positive direction, up, or the negative direction, down. The positive direction up here in the first quadrant, x is positive and y is negative. If I'm going down here in this fourth quadrant, x is still positive, but y is negative. So if I use the next one, which is the sine of theta, the sine of positive theta is going to equal a y. But if I have the sine of a negative theta, that is just equal to negative y. Now, what about the other functions? Well, because cosine is even, the secant of theta is just 1 over the cosine of theta, so the secant is also even. But what about the other pieces? 1 over the sine of theta is equal to the cosecant of theta. So both of these are odd. As well as the tangent and cotangent. They're also both odd functions. Now, how do I use this? Well, what that means is that if you have the cosine of pi over 4, that's the same thing as the cosine of negative pi over 4. And where is that on the unit circle? That's that one right here in the middle. And at pi over 4, that value is the square root of 2 over 2, comma square root of 2 over 2. So both of those are equal to the square root of 2 over 2. Whether it be the top angle or the negative angle in the other direction, this value down here would be the square root of 2 over 2 minus the square root of 2 over 2. I just want to make sure I go back and state something with this. This is true for the secant whenever the cosine is not equal to 0. It's undefined when the cosine is equal to 0. Same thing for the cosecant. Whenever the sine is equal to 0, the cosecant would be undefined.